Good afternoon, everyone. My name is Prakhar Shrivastava, and I am presenting you this particular crash course on manufacturing. And very shortly, we are going to start with the third lecture, where we will continue from the previous lecture. I think that we have covered till the numerical part in the previous lecture. Yes, I think. Okay, so I think that everything is visible and audible to all of you. I just need to check that. I just need to check it from my end. Once we are done, we'll be starting with the lecture. ठीक है चलो. Oh, this lecture is not. Oh, so do you guys have any doubt from the previous lectures that what we have discussed? Do you have any doubt? Okay. So very good afternoon. मेरी आवाज आ रही है? Am I audible and visible to all of you guys? Quickly tell me whether I am audible and visible to all of you. I just need to check that everything is working fine or not. Okay. So we will catch it up. Crash course manufacturing. Okay. Import. Crash course manufacturing. Lecture 3. Okay, done. So hello everyone, my name is Prakhar Shrivastava. I have secured All India third rank in GATE 2016 and then I took admission into IIT Bombay and finally completed my masters from NITI Mumbai. From past 3 years, I'm teaching on I'm teaching on the digital platforms, and in just a short span of time, you can say I have gained experience of teaching approximately 22,000 plus students. So thank you all for your love and support. Thank you all literally from the bottom of my heart. Thank you all. And I hope that you are liking whatever I am teaching and the manufacturing. I'm trying to make manufacturing a very interesting topic, more numerical oriented, more feeling oriented, more conceptual oriented. Is it clear? So today we are going to continue from the part. I think that today we will be starting with the very important process of TIG, that is tungsten inert gas manufacturing. Tungsten inert gas manufacturing. Quickly message in all the groups. I want more people to be live. Quickly message in all the groups. I want more people to be live, guys. Quickly. Thank you all for sustaining, and at the same time a very happy Dhanteras to all of you. Today I think that आज ही है ना धनतेरस, so आज धनतेरस है. Thank you all. हाँ, doubts from the previous class. देखो, my course is more than enough. You won't be getting anything better in 45 hours. This is a 45 hours crash course designed. I think that this is more than enough for you to cover anything. 45 to 50 hours का course होगा and it will be more than sufficient for the last moment. Is it clear? देखो, न्यूमेरिकल्स के लिए आई हैव केप्ट अ स्पेशल सेशन एट 5 p.m. that is the practice session at 5 p.m. and due to like busyness, Diwali is like the next door, so that is why I am a bit busy, so that's why I am not taking 5 p.m. session. But as soon as Diwali is over, every day we are going to have a 5 p.m. session and you would be getting approximately 500 plus numericals for manufacturing. You don't have to worry about that. Anything else? Anything else? Yeah, kal I tried my best to come live, but due to some personal reasons, I was not able to. Okay, so I'm really sorry for that, for the yesterday's loss. But yes, I will try to cover it up, and you won't be having any like the knowledge gap, or you can say you won't be having any like the issue that I have missed with the issue that I have missed the yesterday's class. Is it clear? Chalo, I think that any other thing from my side that I can do. Any other thing? Chalo, let us start with the lecture. Hello everyone, this is a plus course. I will be coming to this part once we are done. If you have liked the course, do listen to whatever I am saying. Okay, chalo. So today we have to start with TIG. Give the heading TIG. Tungsten inert gas welding. This is a very important welding process. Tungsten inert gas welding. Tungsten inert gas welding. So what is the difference between tungsten inert gas welding and the welding that we have discussed so far? So we have discussed two welding, that is shielded metal arc welding we have discussed, and submerged arc welding we have discussed. Now, sir, how TIG is different from these welding processes? Sir, what is there in TIG that we are having extra, or what is there in TIG that is different from the previous welding processes? So please understand. Please try to understand, guys. This is your electrode. Simple. This is my electrode and this is my workpiece. I connect it to the battery. I connect it to the battery. Please try to understand. I am connecting it to the battery. These are the two workpieces. ऐसा लिख लो. These are the two workpieces. Okay, these are the two workpieces and I am connecting it to the battery. I am connecting it to the battery. Now, which thing will be connected to the negative terminal? Quickly tell me which thing will be connected to the negative terminal. You have to tell me which thing will be connected to the negative terminal. Yes, many people are answering. Many people are answering. Very good, guys. Very good. Many people are answering. Yes, you usually connect this to the negative terminal, electrode to the negative terminal and workpiece to the positive terminal. Why? Because positive terminal will be having 2/3 of the total heat and electrode will be having 1/3 of the total heat. And actually we want to melt this workpiece because for welding, melting is required. For melting, heat is required. More heat is given when we are making workpiece as anode. Yes or no? So this is the basic setup. This is the basic setup in front of you. This is the basic setup in front of you. When you are having this basic setup in front of you, यार मुझे comments नहीं दिख रहे. Please do comment, guys. Please do comment. Please do comment, guys. Please do comment. Electrode, very good. अब देखिए, ठीक है. Now very important. Now this is the basic setup. Now if you want to do something different, or you can say if the workpiece is very hard, if your workpiece is hard, then what you will do? Please try to understand here. Now in TIG welding, this electrode is nothing but made up of tungsten. Now in TIG process, your electrode is made up of tungsten. In TIG process, your electrode is made up of tungsten. Please pay attention. If you take aluminium, quickly as soon as you place it for welding, it forms a layer of Al2O3. We have seen this. This is ceramic in nature and it is quite hard. It is quite hard. Yes or no? So aluminium, as soon as you try to weld aluminium, aluminium reacts with the oxygen in the atmosphere and it forms a layer of Al2O3, which is ceramic in nature and it is hard. Now, it is not that easy to melt this layer. So this setup is not going to work. Because instead of that, you are attaching the positive terminal to the workpiece will not melt. Then sir, what should we do? So there is different setup. Please try to understand. अरे just a second guys, ये थोड़ा सा error दे रहा है. Error क्या दे रहा है? चलो. Now, please try to understand why not to do like this. Suppose this is your electrode and now I am connecting workpiece. This is your workpiece. These are your two workpieces. Now, what I am doing? I am connecting it to the battery or the power source. I am connecting it to the DC power source. So instead of putting the workpiece on the anode, I put the workpiece on cathode. Sir, इससे क्या होगा? What will happen if we put workpiece on cathode? देखो. Then what will happen? Your electrons will be gathered here. And here you are having the positive force. And now electron will try to jump in the opposite direction. Yes or no? Electron will try to jump in the opposite direction. Electron will try to jump towards cathode. Electron will try to jump towards cathode. Electron will try to jump towards cathode, and that is why this movement of electron in the upward direction actually breaks the film of Al2O3. Duk, 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 duk. You are trying to understand, the electron gains potential, it tries to go up. So the electrons are trying to go up. When the electrons are trying to go up, they actually break the layer of Al2 over 3. They actually break the layer of Al2O3 over it. Yes or no? Are you understanding? Yes. अगर समझ में आया तो yes लिखो, फटाफट yes लिखो. Because I don't want any lazy people in my lecture. I want the people to be having the conceptual clarity, the feeling of the topic, the understanding of the ability, the understanding of the topic, so that they can solve numerical in the final exam. I want yes if it is clear to all of you. Yes लिखो जल्दी if it is clear to all of you. That is, electron will now try to jump from workpiece to electrode. Why? Because negative terminal is attached to the workpiece. So the electron will be gathered on the border of workpiece. Electrons will be gathered on the border of workpiece. Electrons will be gathered on the border of workpiece. And now, if they are gathered on the border of workpiece and a positive force is trying to pull them up, so that is why they will move in the upward direction, breaking the film of Al2O3. Yes or no? So this is known as, first of all, when the polarity is changed, this is known as reverse polarity. This is known as reverse polarity. First of all, this is known as reverse polarity. This is known as reverse polarity. Why we have given reverse polarity? So that the kinetic energy of the electron can break the hard or Al2O3 sheet. Is it clear? When you are having this polarity, ये क्या हो गया? I'm really sorry guys. ठीक है, when you are having this polarity, that is the workpiece will be connected to the positive terminal and electrode will be connected to the negative terminal that we have seen yesterday. This is direct or straight polarity. Straight polarity. Polarity. Straight polarity. When we are reversing the polarity, that is connecting the workpiece to the negative terminal and the positive terminal will be connected to the electrode. The positive terminal will be connected to the electrode. Then we will call it as reverse polarity. Why we have given the reverse polarity? So that electron can move in the upward direction, cracking the film of Al2O3. Yes or no? Now, since positive is connected to the electrode, now in this case, 2/3 of the heat will be generated at electrode and 1/3 of the heat will be generated at anode, okay, or the workpiece. Now, since the heat is increasing, the melting rate of electrode will also increase. The melting rate of electrode will also increase, and that is why now if electrode is melting fast, it is of no use. I want my workpiece to melt. I don't want electrode to melt. So that is why we try to make this electrode of a material such that it becomes non-consumable electrode. Non-consumable electrode. Is it clear? Now, what is the material which will not easily melt? That is tungsten. So that is why the electrode is made up of tungsten when we are using the reverse polarity. When we are using the reverse polarity. Is it clear? So whenever we don't want our electrode to basically melt, or we want our electrode to act as a non-consumable electrode, we make it of tungsten, and tungsten is having high melting point. That is why it is used. Yes or no? Everyone understood this or not? Don't you think this is a very clear concept I have given you? This is a very crystal clear, amazing concept that has been given to you. You just have to ask the question if there is any doubt. If you don't have any doubt, please write clear. CLEAR. If this concept is clear to all of you, why we are changing the polarity? Why we are changing the polarity? Because we want to use the kinetic energy of electron to break the film. And now in reverse polarity, positive sign is attached to electrode. So wherever positive sign is attached, that is anode. At anode we have high melting or high heat consumption. Okay, so we don't want our electrode to melt because of high heat. So that is why we are making electrode of tungsten. So our melting of electrode is also stopped using tungsten, and my workpiece is also welded because the layer of Al2O3 is removed. Yes or no? Yes or no? See, I don't know about state level examination which you are talking about. State level का क्या मतलब है? State level पे बहुत सारे exams होते हैं. There are a lot of examination at. अच्छा, my English is clear ना? Are you able to understand my English? Is there any issue? Specifically the people from south of India, because they actually have a difficulty in understanding Hindi. That's why I'm trying to take this course in English. Chalo. So the concept of TIG welding is crystal clear to you. In TIG welding, we reverse the polarity and use the tungsten electrode. That is the only difference. That is the only difference. So now shall we write? Guys, quickly tell me. Shall we write now? I'll really appreciate if you participate in answering. I will really appreciate. तो यार ये मेरा please answer the question, then only I will be able to move forward. No, melting point of aluminium is low. Aluminium is a ductile material, but the issue with aluminium is the ceramic layer of Al2O3 that is very hard and having very high melting point. मिथिलेश कुमार, actually हिंदी में बीच बीच में बोलता भी हूँ, but actually what happens that there are a lot of courses in Hindi, so the people have requested that like I should take the course in English, so that is why I am taking it in English, but you will be able to understand. बिल्कुल समझ में आएगा, कोई दिक्कत नहीं है, कहीं भी कोई दिक्कत नहीं होगी. Is it clear? थोड़ा सा इशू हो रहा है. चलो, so then we should move forward. समझदार वेल्डिंग तक हमने लिख लिया था. आई होप यू गाइज आर मेकिंग प्रॉपर नोट्स. नेगेटिव देखो, वेरी गुड. मेनी पीपल हैव दिस डाउट. नेगेटिव इज फॉर कैथोड और एनोड. क्विकली टेल मी, नेगेटिव इज फॉर कैथोड और एनोड. नेगेटिव इज फॉर कैथोड और एनोड, जल्दी बताओ. क्विकली टेल मी, नेगेटिव इज फॉर कैथोड और एनोड. I will tell, not a very big deal. देखो, अब प्रॉपरली लिखना चालू करो. Wherever negative sign is there, negative sign corresponds to cathode and positive sign corresponds to anode. And Fe2 plus, this is a cation, and Cu2 minus, Cu2 minus तो नहीं होगा, Cl minus लिख लो, क्लोरीन माइनस लिख लो, क्लोरीन माइनस, this is anion. Is it clear? Negative side is cathode, positive side is anode. Is it clear? Negative side is cathode, positive side is anode. Chalo, now let us write and let us draw the diagram. So the process is TIG, and it is also known as, please pay attention, it is also known as tungsten. This is tungsten inert gas welding. This process means tungsten inert gas welding. Sir, यहाँ inert gas कहाँ है? यहाँ inert gas कहाँ है? Sir, where is tungsten inert gas welding? Where tungsten is inert gas welding? I am not using any gases here, so please pay attention. I'll draw the diagram and please update this diagram. ठीक है? You all understand this is a tungsten electrode because it is non-consumable in nature. This is a tungsten electrode, but because it is non-consumable in nature. Now there is a shielded area. There is a shielded area. This is like a shield. This is a shield. And we try to pass the gas from here. We try to pass the inert gas from here so that welding takes place in an inert environment. Why inert environment? So that it should not react with the atmosphere, because if it will react with the atmosphere, again quickly a layer of Al2O3 is formed. Yes or no? Are you trying to understand? That is why I am having inert gas, so that the atmosphere around the welded joint or the atmosphere around the arc should be protected from the attack of atmospheric gases. Because if the atmospheric gases is acting, as soon as the layer of Al2O3 is broken, again the aluminium will react with the atmospheric oxygen and form a new layer. So that is why I don't want that. So that is why I am using inert gas environment here. I am using inert gas environment here. Is it clear? Is this thing clear? Direct current, reverse polarity, straight polarity, I will teach, don't worry. But first understand tungsten inert gas welding. If it is clear to you, then write yes. If this thing is clear to all of you, please write yes. If this thing is clear to all of you, please write yes. Now, understand. Okay? What are the gases that we are going to use? Please try to write. A basic concept मैं आपको दूंगा, but I want you to write this basic thing as well. Quickly guys, quickly write these small things. In TIG, electron is made up of high melting point material like tungsten. Please note it down. In TIG, electrode is made up of high melting point material like tungsten. A passage is provided for the flow of shielding gases / inert gas. For the flow of shielding gases / inert gas. Shielding gases / inert gas. So this is nothing but shielding gases. Shielding gases or inert gas. To protect the welded joint from the attack of atmospheric gases. To protect the welded joint from the attack of atmospheric gases. Since, इसके बाद third point लिखो. Since the electrode is non-consumable, please tell me if the electrode is not consumable, which is one extra thing we will use. I have given you this concept. If the electrode is not consumable, what is that one thing that we will use? If the electrode is not consumable, what is that one thing we will use? Quickly tell me. A passage is provided, I am repeating, a passage is provided to maintain the flow of shielding gases / inert gas to protect the welded joint from the attack of atmospheric gases. From the attack of atmospheric gases. Yes. Since the electrode is not consumable, we will use a filler rod. To fill the gap. Application में लिख लो. TIG is specifically used for aluminium and its alloys. Aluminium and its alloys. ठीक है, प्रोसेस आपको पता है. That is, workpiece will be connected to the anode, the electrode will be connected to the cathode, the electron movement will break the Al2O3 layer and the machining or the welding will take place. ठीक है, ऐसा लिखो. The process, change the paragraph and write. The process used of cleaning the Al2O3 layer The process used of cleaning the Al2O3 layer with the help of movement of electron is known as cathode cleaning. ये जो चीज थी ना, this operation, that is electron is breaking the layer, this operation is called as cathode cleaning. Cathode cleaning. Is it clear? Obviously, if you change the terminal, cathode and anode will change. It is not fixed. Anode is not fixed. You can make the electrode also as anode, workpiece also as anode. Is it clear, Vignesh? Yes, change with the terminal you will be having. Cathode cleaning is clear. This is an important term. It has been asked. It has been asked in one of the competitive examination. Is it clear? अब मैं लिखा तो नहीं सकता हूँ. I will try to share the notes. But it is whatever was important that I have given to you. एक बार पोलैरिटी में समझा देता हूं. लिखो कॉन्सेप्ट ऑफ पोलैरिटी. Concept of polarity. Concept of polarity. Understand. When the electrode is single and you are having the workpiece, please try to understand. It is connected to the DC power source. Positive is connected to the workpiece. Negative is connected to the electrode. This is known as direct polarity. ठीक है? 2/3 heat will be generated on workpiece. Mostly we do it in TIG only. 2/3 heat will be generated on workpiece. 2/3 heat will be generated on the workpiece. Is it clear? Is it clear? Chalo. Similarly, if this is electrode and this is your workpiece, it is connected to a system, and now positive terminal, that is this acts as anode. Positive terminal जहां पर भी होगा that will be anode. So positive terminal is attached to anode, negative terminal is attached to cathode. This is known as reverse polarity. And now 2/3 heat will be generated on electrode. In such cases we use non हेलो हाँ जैसे क्लास चल रही थी मैं करूँ आपको थोड़ी नहीं कुछ जरूरी ठीक है हाँ 2/3 heat will be generated at electrode, so that is why we have to use non-consumable electrode. And when we are using non-consumable electrode, we also use filler rod. Is it clear? Because if your electrode is non-consumable, from where your gap will be filled? Now there is third scenario also. This is your electrode, this is your workpiece, and now I am connecting it with the AC power source. I hope you understand AC power source. AC power source matlab it will be for half of the cycle, electrode will be positive, workpiece will be negative, then for another half workpiece will become positive, Then for next cycle, workpiece will become negative, negative, positive, negative, positive, positive. Is it clear? So that is why this is known as AC polarity. This is known as DC direct polarity. This is known as DC reverse polarity. This is AC polarity. In this, 50-50% heat will be generated on both. 50-50% heat will be generated. 50-50% heat will be generated and equal melting from electrode and workpiece takes place. Is it clear to all of you? Why, Mayur Khatri, I have told you why to reverse polarity, because when you are having reverse polarity, electron will move from the workpiece towards cathode, and while they are moving in the upward direction, the kinetic energy is high when they are leaving the workpiece, and when the kinetic energy is high, we are using that high kinetic energy to break the layer, because without breaking the layer they cannot go up, they cannot go to cathode, sorry, they cannot go to electrode. Is it clear? They cannot go towards electrode. So if it is reverse polarity, the electron will be released by the workpiece, and then the movement of electrode in the upward direction will break the layer that is over the workpiece, and hence the layer is broken, the welding will take place. Is it clear, Mayur Khatri? Is it clear, Mayur Khatri? Is it clear? What do you mean by cathode cleaning? Removing the layer of oxide from the workpiece. What is cathode cleaning? Removal of the layer of oxide from the workpiece. Is it clear? Is it clear? Now, एक और चीज होती है. See, now we don't want electrode to melt. So how to delay melting of electrode? Melting of electrode, ये भी आपको पता होना चाहिए. So what we do, this was your cathode, so instead of this I make the cathode of this shape, so that the bottom area is more, this bottom area increases, so the heat required to melt this also increases, and that is why the probability of melting decreases. Is it clear? Bottom area is increased, bottom area is increased. Is it clear to all of you? Is it clear to all of you? This is very important, guys. In order to delay the melting of tungsten electrode, okay, in order to like delay the tungsten electrode, you are basically doing what? You are increasing the diameter of tip of electrode. Okay, that is increasing diameter of tip of electrode, tip of electrode. Is it clear? Is this thing clear? Why we don't want it to melt? Because, please note down, if tungsten melts, if tungsten melts and dip into the weld pool, if tungsten melts and dips into weld pool, due to its mechanical properties, due to its mechanical properties, it will make welded joint brittle. It will make the welded joint brittle. It will make the welded joint brittle. it will make the welded joint brittle. Is it clear? And I don't want that. So that is why I try to stop melting of electrode. How we can stop melting of electrode? How we can stop melting of electrode? By increasing the diameter of the tip. If you increase the diameter of the tip, the bottom area is increased, heat required to melt increases. Heat required to melt increases, because now more content of heat is required because the volume is large. Yes or no? Are you trying to get the feeling of what I am trying to say? Is it clear? Is this thing clear to all of you guys? Quickly tell me, is this thing clear to all of you? Is this thing clear to all of you? Quickly tell me. Shall we move to next process then? Likho. In order to protect the welding area, in order to protect the welding area, in order to protect the welding area, shield or inert gases is provided. Shielding or inert gas is provided. Example, argon, helium. Argon, helium. Argon, helium. Sometimes argon, helium, etc. Sometimes CO2 is also used. Sometimes CO2 is also used because of its low cost. Because of its low cost. So please tell me guys, CO2 यूज करेंगे तो क्या मैं इसको TIG बोल पाऊंगा? Can I call this process as TIG? Can I call this process as TIG when I am using CO2? Quickly tell me. TIG means tungsten inert gas welding, and CO2 is not an inert gas. So why you will call it as TIG? You will not call it as TIG. When the shielding gas is not an inert gas, we call it as GTAW, gas tungsten arc welding. Gas tungsten arc welding. Is it clear? So please don't get confused between TIG and GTAW. Both are same process, just in TIG inert gas is used. Just in TIG inert gas is used. And when we are not using shielding gas as an inert gas, we call it as GTAW. That is different. Alchemist Potter, that is different. We will come to that. GMAW पे भी हम आएंगे, but अभी GTAW है. That is gas tungsten arc welding. Gas tungsten arc welding. Is it clear? Is it clear? Is this thing clear to all of you? Shall we move forward? So please give the heading metal inert gas welding. Please give the heading. अभी आपने TIG कर लिया. Now we will move to the next process of MIG. TIG, MIG आपने दोनों सुना होगा. MIG, metal inert gas welding. Metal inert gas welding. किसी को कोई डाउट हो तो पूछ लो guys. Please ask me if you are having any doubt. The next welding process is MIG welding. Metal inert gas welding. This is really important. Metal inert gas welding. Metal inert gas welding. So in metal inert gas welding, what will happen? In metal inert gas welding, what will happen? देखो, same process I am using, but now if it is not possible to use tungsten, can you use it? Can you say it tungsten inert gas welding? No. If we are using some other metal, that too in form of wire. Do you understand now why wire is used? Because it is now Suppose it is not possible to arrange an electrode which is having high melting point. So you will use some other metal which will be having low melting point. It will basically melt and get dips into the weld pool. Weld pool में गिरेगा ना वो मेल्ट होने के बाद, वेल्ट पूल में मिलेगा ना वो मेल्ट होने के बाद, इट विल ड्रॉप इनटू द वेल्ट पूल मेकिंग द स्ट्रक्चर ब्रिटल. सो दैट इज व्हाई वी कैन नॉट यूज टंगस्टन. We want some other metal, and since it is melting again and again, we have to change the electrode that we have saw in submerged arc welding. Yes or no? So that is why I am using wire electrode. The process is almost same. ठीक है, the process is almost same. देख लो, this is a wire electrode. Here you are having an arc. This red color one is your arc, and now you are having the shielded gas area. There will be a shielded gas area. Now I am changing the electrode. I am just changing the electrode. That's it. From here the inert gas will flow. From here the inert gas will flow. It will be connected to a power source. Here you are having a workpiece, and both of them will be connected to a power source. This is your power source. This is your power source. Is it clear? It can be AC source, DC source, whatever you want. But this is your setup. Is this thing clear? Now, this is wire electrode, or you can say bare electrode. Wire electrode slash bare electrode. Wire electrode or bare electrode. Is it clear? Chalo. Please note down, guys. Please note down. Please note down. That is a small request from my side. In MIG welding process, in MIG welding process, in MIG welding process, in MIG welding process, the electrode is in form of a wire. Note down, ये आता है. This is an ESE question. These are ESE question. The wire is in form of electrode in MIG. You should know it. That in MIG welding process, the electrode is in form of wire, which is continuously supplied in the welding area, which is continuously supplied in the welding area, which is continuously supplied in the welding area with the help of a motor. Okay, ये नीचे जाता जाएगा because the electrode is getting consumed. It will go down. It will go down. चलो. Welding area is protected by the flow of inert gases. Welding area is provided. Welding area is provided with the flow of, or welding area is protected with the flow of inert gases. मेरी गाड़ी की क्या हटाना है क्या? मैं हटा देता हूँ. एक मिनट रुक. Welding area is provided with the flow of inert gases. ठीक है? Same, everything is same. Everything is same. Just instead of tungsten electrode, I am using a wire electrode which is made up of some metal. ठीक है? Now, when CO2 is used as a shielding gas, 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 It is known as gas metal arc welding. Gas metal arc welding. Gas metal arc welding. Gas metal arc welding. Is it clear? Gas metal arc welding. Now there is a serious problem with these operations. There is a defect. There is a defect in arc welding. The defect is known as arc blow. Please try to understand. Please try to understand. Suppose these are the two workpieces that needs to be joined. These are the two workpieces that needs to be joined. Please try to understand. Now, this will be the joint area. This will be the joint area. See, this is the complete crash course on manufacturing for GATE exam. That those lectures are detailed lecture, and 90% or 75% of these lectures will be covered here only. You don't have to worry about that. You can continue with this particular lecture every day. I hope all the people in the lecture you are enjoying it. क्या production boring लग रहा है आपको? I just want a small feedback from your side, guys. Do you find production to be boring? Quickly, guys, quickly. Have you enjoyed this topic? Now, please try to understand when I am doing machining on this end. I will draw this diagram. Now my electrode is moving like this. So now, suppose this is your workpiece number 1. And this is your workpiece number 2. Now, you want to fill this gap with the help of electrode material. You want to fill this gap with the help of electrode material. Yes or no? You want to join these workpieces. Now, suppose I am doing the machining on this part. Suppose I am doing the machining on this part. Please try to understand, guys. Third diagram I will make. This is your electrode and this is your workpiece. Now electrode and workpiece are clear to you. I am actually joining it, or I am doing the machining or welding across the length of the workpiece. Now what will happen? Please try to understand. Here you are having an arc. Yes or no? Now arc is nothing, but this is arc is not electrically neutral. Due to the movement of electron it is there. So that is why arc is a charged particle. And now when the current is passing through the workpiece, magnetism will be induced in it. Electromagnetic induction. Have you understood it? Electromagnetic induction. Whenever current is passing, the induction takes place. The induction takes place. Here also it takes place. Is it clear? Now, since the strength is on the right hand side, since this is charged, since the arc is charged, it will try to bend towards right, because more rings are there on the right hand side. The length of the workpiece is more on right hand side, and that is why the strength of the magnetism is more on right hand side. So that is why the arc will try to bend like this, and the actual arc looks like this. The actual arc looks like this. Is it clear? Don't you think this is a defect? Don't you think this is a defect? Don't you think this is a defect? Obviously this is a defect. This is a major defect. All of you understood or not? Yes का answer चाहिए. मुझे पहले answer चाहिए. Quickly answer this thing, then only I will be moving forward, guys. Quickly answer this and then I will be moving forward. जल्दी बताओ. Is this thing clear? चलो सब सही है. Now suppose now this arc should be straight. This defect is known as arc blue. This defect is known as arc blue. Please write it down. When the fixed polarity power source is applied, please note down, this is important. When the fixed polarity power source is applied across electrode and workpiece, when the fixed polarity power source is applied across the electrode and the workpiece, due to flow of current, magnetic lines will be formed around the conductors, both electrode and workpiece. Magnetic lines will be produced. Magnetic lines will be produced. Magnetic lines will be produced across the conductors. Across the conductors, that is electrode and workpiece. Now, arc is established between workpiece and electrode. Arc is established between workpiece and electrode, which is charged in nature. It is charged in nature. ठीक है. Change the paragraph and write, when the welding is performed at the center of the workpiece, when the welding is performed at the center of the workpiece, when the welding is performed at the center of the workpiece, the arc remains straight. The arc remains straight. But when welding is done on one of the ends, when welding is done on one of the ends, but when welding is done on one of the ends, the arc will be deflected towards the workpiece. The arc will be deflected towards the workpiece because the arc will be deflected towards the workpiece because most of the magnetic lines are concentrated towards workpiece. Are concentrated towards workpiece. Now, deflection of arc from its mean path. Deflection of its arc from its mean path is known as arc blow. Is known as arc blow. And the defect related to this arc blow is known as spatter. The defect due to this arc blow is known as spatter. S-A-P-T-T-E-R, written on your screens, is known as spatter. Now, what is the solution? What is the solution of this? Can you give us some solution? The first one is use AC instead of DC. Now what will happen if AC is there? One time the arc will be deflected here, the other time arc will be deflected away. towards the workpiece, away from the workpiece, towards the workpiece, away from the workpiece, towards the workpiece, away from the workpiece. So net effect will be the straight line. Net effect will be the straight line. Is it clear? So that is why AC में polarity change होगी. In AC, polarity will change continuously. So the direction of magnetic induction, the direction of force of magnetism is also changed. Once it will pull the arc towards it. In the next cycle, it will push it, then pull it, then push it. The arc part. Is it clear? So that is why using AC is much more convenient than DC. Second. Is it clear? Second. Use arc of shorter length. Use arc of shorter length. Third, you can important do. देखो, the electromagnetism is based on the electricity. Electricity is nothing but current. If you decrease the current, the strength of the magnetic lines will also decrease. Have you studied this in 12th class, that the strength of the magnetic lines is directly proportional to the current flowing to it? If current decreases, automatically the strength decreases and automatically the force of attraction decreases. Is it clear? So please note down. Decrease in the current setting of welded joint. ठीक है. And fourth very important part, what you can do, if there is a blow here, please keep another plate of opposite induction here. Simple. So that now this part will become, you can say this part will, on both the sides of the arc you are having equal induction, or you can say equal flow of current. So that is why now the arc will become straight. Now the arc will become straight. When the arc will become straight, when the electromagnetic force on both the sides are equal. Otherwise the arc cannot be stable. The arc cannot be stable. Yes or no? So this is another way in which you can do it. ठीक है, चलो. So these are some of the important points. I think that you have written it. Let us move to the next topic. देखो, क्रैश कोर्स है इसलिए जल्दी करवाना है. इज इट क्लियर? इफ यू आर हैविंग एनी डाउट प्लीज लेट मी नो. कोई डाउट हो तो पूछ लो, कोई दिक्कत नहीं है. इफ यू आर हैविंग एनी डाउट लेट मी नो. आई जस्ट कम बैक आफ्टर ड्रिंकिंग सम वाटर एंड देन वी विल कंटिन्यू. If you have any doubt, please go through the previous pages, because now we are done. We are almost done with arc welding. सिर्फ electro slag welding बचा हुआ है, that I will consider afterwards. But if there is anything that I have left, please let me know. Is it clear? Arc welding is done. I hope that you have got the feeling. Anode, cathode, positive, negative polarity. If anyone is having any doubt, please do ask, guys. Please do ask. Otherwise, there it is of no use. हाँ हो गया यार। ओके गाइस, डाउट तो आपके देखने पड़ेंगे, कैसे देखने? ओके, what are your doubts? Quickly tell me. रोज की नौटंकी है, दो लोग आते हैं। I don't think you guys are having any doubt. I think that I am audible now. If you are having any doubt, please let me know, because then resistance welding I will start. Electro slag, electro gas welding है, that I will be covering, not a very big deal. Apart from that, कुछ और हो तो बताओ. हेलो. अच्छा ठीक है, बस 10 मिनट और भेज दो, मैं 10 मिनट में करता हूँ. चलो गाइस, देन आई थिंक दैट आई एम डन. वी विल स्टार्ट अगेन, स्टार्ट फ्रॉम दिस पार्ट. ठीक है, वी विल आर्क फ्लो आपको समझ में आ गया होगा. So just a second, I'll just go back to the slide. You should know about the plus subscription. So if you have liked this particular video and if you have liked this particular course, you should understand that there is a paid course as well that you should target for. It is much more convenient. It is much more structured. It is having, you can have more than 100 plus faculties for the mechanical, like for the gate examination, and you will be getting in plus subscription. You will be getting the live classes, the crash course, the rank improvement batch, the weekly test to monitor your growth. Doubt clearing session will be there after every third lecture, and the sessions will be conducted in English and Hindi. And there is a bigger subscription that is available where you will be getting one personal mentor for your preparation part. You will be getting the study material, the study planner, that is what to study, when to study, and how to study. Booster sessions are there to keep your pace and motivation up. And my personal favorite, that is personalized test analysis. Test all of us give, but we don't understand that what outcome, or like what is the thing that we can actually find out from this thing. Is it clear? What is the thing that we can find out? So this is it. And now what are the charges? So for plus subscription, 1 year costs 27,225, 18 months cost 34,650, and 2 year cost 39,600. Okay, but this is only applicable only after you apply the code. Which code you need to apply? Prakhar, PRAKHAR, Prakhar 21, or you can also apply the code crack 10. Any one of them you can apply. What are the charges for iconic subscription? So it is 45,225 rupees for 1 year and 66,600 rupees for 2 year. But only and only after you apply the code. That is Prakhar 21, PRAKHAR 21. This is a crash course, and चलो फिर then I think that we will wrap up. कुछ doubt हो तो पूछो. I'll give the links also. So if you want to follow us, you can follow me. You can please don't forget to like us on Facebook. Okay, please don't forget to like us on Facebook. This is the Telegram channel of our team, that is Unacademy ESE GATE, where all the videos are uploaded, say like updated. And at the same time, these are the channels that we are running right now. That is Unacademy MEPI XE, Unacademy GATE question SSC if you are preparing for SSC and other examination. So this is all in all. So thank you all for your love and support. And don't forget to check back every day at 2:30 p.m. every day at 2:30 p.m. we are having this crash course on manufacturing, and every day at 5 p.m. I try to keep practice session practice session. So this is more than enough for you to get approximately 13 marks out of, or you can say 90% of the syllabus will be covered here. And practice will be done, the revision part will be given. So I don't think you would be facing any difficulty. If you think that, okay, is it clear? Chalo. So is there any other doubt, or we'll meet tomorrow? Thank you, all the best. Hope to see you soon. Bye bye. प्रैक्टिस सेशन यार अभी तो नहीं हो पाएंगे बिकॉज सी like festive season is going on, the team is on vacation, I am taking these session just for the sake that you should not have loss. So tomorrow also we will have session, then 2 days holiday, then on 16th we will again start back. We will again start back on 16th. We will again start back on 16th. Is it clear? Chalo. Any other doubt from your side? Don't. If you have not liked the video, please do like the video. If you have not liked the video, please do like it. Chalo. Anything else? Thank you, all the best. Hope to see you soon tomorrow. Bye bye.